Hello again, I'm Bill Wagner.
And I'm James Sturdivant.
And now let's look at some of the examples of using generics in the .NET framework in the core base class library. Now, one of the things that we want to do as we walk through these demos is understand that earlier we walked through those non-generic versions of some of the same classes. And that's because historically .NET 1.0 did not support generics. That was something that was added in the second release. That's why the team had this choice of where they had some of these, we call them classic style containers and so on, before generics were introduced. And that's why we see both in the framework. It wasn't that they wanted to necessarily provide both, but just that generics weren't part of the initial release. So the language didn't support it, the CLR didn't support it, but in the next release when it was added, all these capabilities were added. So there's 4 different areas that we're going to look through in this code review. We're going to look at list of T, and we're really going to contrast that with that array list class, which is its counterpart in the non-generic world. We're going to look at task of T, which is a new type that's part of the task parallel library. We're going to introduce the lab, and then we'll come back in the second clip and we'll discuss how we went through and one possible solution to the lab for you.
Great. So we're going to start out by taking a look at the ArrayList class in the MSDN documentation, and then we're going to compare that to the list type of T. So down here, we've already kind of seen this before. What we're going to take a look at here is just a quick reminder of what this looks like. So in the constructors, we have the couple simple ArrayList constructors that initialize the various collections and then potentially the size of the array. And if we come down, we've got a few of the properties such as count and capacity. And when we go down to the methods, we'll see that we have methods like add object and binary search. And we're passing in the object type into those methods. Now, we're going to take a look and compare this.
And a classic iComparer.
Yeah, and a classic iComparer there. And so we're going to take a look and compare this to our list type of T. And when we go and look at that here, what we see is when we come down to the constructors, we now no longer are passing the type of object, but we're actually passing the type parameter here. And we also see that in list of T. We see we have some very similar properties. And then when the methods come in, we have the T type parameter. Now what I'm going to do here is actually compare these two lists of methods. You can see when we look at the add method here, we have object and we have type T on the right for the list type of T. And what happens here is we can actually almost do a control find for object and replace it with T. And so that's a key component to kind of identifying some of these methods here.
And that's effectively what the compiler does. When you instantiate a list of some type that's not T, the compiler replaces it with the specific T with a specific type.
Great. So next we're going to go and actually take a look at what list type of T looks like inside the code. And up here, what we're seeing is the public class defines this type parameter here. And it actually implements iList of T. So we'll actually dive down in and take a look at what iList of T looks like.
I think that would be something like iList, right?
You got it. So iList looks very similar, but what you can see here is instead of defining an integer or the object, it's actually using T in place of those things. And it's also implementing type of iCollection. So we'll take a quick dive down in there. iCollection of T, yes. Which is then is also implementing IEnumerable. And so you're starting to see this inheritance of all of these interfaces and the generic interfaces that they represent. And
it's all the same type parameter. So iList of int would implement iCollection of int, which would implement IEnumerable of int, and so on. Right?
Yep.
Because it's bound to the way that iList of T is defined, that it's whatever T it uses is going to be the same type parameter for the iCollection part and the IEnumerable part.
Yep, you got it. And so when we start to look at these interfaces, it's a little bit easier to see here that this T is where we would actually put the object. And so now when we specify integer, anytime you see this T is where we actually would conceptually identify it as an integer or a string or a student
or whatever the type parameters for that particular object. If
Yep.
I made a list of, or a collection of customers or a collection of packables, that would be an iPackable.
Yep. So let's go back up to list and take a look at the sort method inside list, because that's a really great example of where these generics kind of work very well together. So I'm going to go ahead and find this sort method. So down here we see there is a few different sort methods, but the one we're really interested in is this one down here. When we take a look at the method signature, what we see all the way down to the right here is we actually get that iComparer of type T. And so this is where we saw the, before we would see the non-generic version of that comparer, and now we actually have to use that generic version of the comparer here, which allows us to get that type safety even at that interface level.
Right, so if I'm sorting a list of strings, my comparer has to be something that compares strings.
Yep.
That's that same type parameter. Okay.
Cool. So is there anything else you wanted to take a look at inside the
inside the list? There was one other thing that I wanted to look at in there. So we looked at sort, we looked at some of that. Now that one only takes one type parameter, so it's always just got list of T. And I think one of the things that we really didn't cover, if we looked at, say, our dictionary of T key, comma T value, we can have multiple type parameters. So we can, and they don't have to be the same. So I think that may be one of the things that's worth kind of looking at just a little bit.
Okay.
Just to contrast that, because it was one of the things that we looked at the hash table class, and this would be kind of the the generic equivalent of that. So I think that ends up in the same solution as well.
So I'm just taking a look for the dictionary.
Let's see if we can find that. Hopefully we can find that without too much trouble.
Yeah.
But I think that would be one of the important ones to take a good look at. Ah, hey, there we go.
So
I think we even find using it. We can.
There's the dictionary. So we're going to go right to the definition.
Just F12. There we go. Okay, so now so now I've got two generic parameters, and I think that would mean they don't have to be the same type, right? I can make a dictionary where my keys are strings, and my values may be, customers or websites or whatever, and it's going to distinguish it, and the compiler is going to do that work. Unlike, say, the hash table where my keys were system.object and my values were system.object, and I might make the mistake of mixing them up in some API somewhere. The compiler will make sure I can't do that here with this type.
Right, and so you can also see down here that they've included a private structure down here, and they're using the key with the type T key, and over for the value they're using the T value. And so they're getting those from the two type parameters that are specified in the class up there. And so you get that type safety when you're trying to access the key and the value.
Even in the private fields that they're using internally, they're making use of that same kind of type safety.
Right.
Cool, okay. Getting that same kind of reuse from that generic algorithm.
Great. So I think next we're going to take a look at the task class. So I'm going to switch back over.
Let's talk about task of T as you get that code loaded. So task of T is meant to represent some asynchronous work in the task asynchronous protocol. So a task of T is some work that's being done asynchronously. And when that asynchronous work finishes, the result of it is going to be an object of type T. So like if it were, say, a web request, the result might be the string that comes off the stream from the network stream. If it's a file read, it might be the bytes that got read from the file. Something like that, right?
Okay. Yeah.
Okay. So how does task of T work, and why is the generic stuff helping us there? And I notice there's no task. Well, there is a task class, but the task class doesn't have a result. So it returns, it's a task that does work, but doesn't return a value. So there isn't a non-generic like task of object anywhere. Because that one is new enough, it didn't come into play before generics were in the language. So there's just the generic version.
Right. Yeah, so we're going to take a quick look here at the MSDN documentation for the task of type T result. And so you can kind of name that, generic parameter however it makes sense for you to communicate what this is actually doing. And so here we're actually saying it's the result that's going to come back from our asynchronous processing. and we're specifying what the type value might be. And so we can specify whether it's a string or an integer or some student or some other object that we have created ourselves.
Right. So there's nothing magical about just using T or T1 or T2. It's just sort of a convention because it stands for a type. What goes in there is a type, not a variable, like not name or age or something. It's the type, string or int or whatever.
Yeah, that way when you're working with it, you actually know that it's a type, and in this particular instance, they're doing T of result, so that you know that's a result returning from a operation.
So sort of like that, interfaces start with I, generic type parameters start with T. Just a convention. Okay.
Exactly. So back on the documentation here, we can see there's a variety of different constructors. And we're actually seeing some of those delegates that we kind of briefly touched upon. We're going to kind of briefly go past that for right now because we're going to touch upon that in the next module that we talk about. But you can see that we can pass different types of results and get them to return.
Right. So for right now, just think of that as a way to, that func of T result is the work that's going to be done asynchronously. It's some method.
Yep. And so you can also see there's a whole bunch of properties that we get access to. We can find out the state that the object is in. We can find if there was any exceptions that were thrown during this processing, and if there was any results and what the status of this task is. If we go down to methods, there's a whole bunch of
result would be of type T result.
Yes.
And that's one of the places where
you can see that right here. That it says it gets the result of the value for the T result that was specified when this class was instantiated. And there's a whole bunch of different methods that we're not going to dive too deeply in here that allow us to be able to continue on with other actions once those results come back. But so let's go take a quick look at the code. Let's switch over to Visual Studio here. Yeah. And I've got my task class loaded. I'm going to bring us back up to the top. And, oh no, I think I'm in the wrong space. So, okay. So there's actually two classes here that kind of work in parallel. This is that task class that you mentioned before, but what we actually are the one we want to be looking at is actually in this future class. And because it represents a task that has been returned from some operation that we ran in.
Right. So somebody took the name task.cs and they had to just come up with a different name for task of T. Okay. Yeah. Naming things. It's always hard.
Exactly. It's one of the hardest things, right?
Right.
So on our public class here, we have task of T result inherits from task. So we're pulling in all of those features that we just saw from that task class that I was kind of moving around in there. And I think, again, the nice thing that we can notice here is that this T result is something that's going to be stored internally.
Okay.
And so we see that the object is being used inside of the class. And this is that member variable, and this is where we were kind of talking about in the previous module where the result, if you're not using the result internally, then you potentially could just use a generic method,
right?
Yeah.
So here we're storing. It's going to have its default value, so it's going to be null since if the task hasn't finished yet. And then I'd assume somewhere along there, as the task completes, it's going to store that value, so I can retrieve it with that result property.
Yes. Okay? So maybe we'll take a quick look at that result property. Oh, I think actually a better way to do this is to come up here and look through here.
Yeah.
Task.result.
There we go.
And so there's a bunch of extra information in here, but you can see at the very end, at the end of this property, we're going to be getting the actual value if we check to see that it's actually been completed.
If it's been completed, we're going to do it. Otherwise, we're going to try to figure out if it's supposed to do it. Yep. And for people that have used the task thing, that part in the middle does something interesting where if the task hasn't completed, and you're trying to get the result, it's going to block until it's completed.
Oh, wow. Okay.
So what will happen, right, so if you've got a task that's running and you look at its result property, that code will block until it finishes, either successfully or by throwing an exception,
Okay, cool.
So that's what that code is doing, is if it's, and that first part is whether or not it wants to, wait notification is enabled. So if it's not, you can set that not to work that way, but in general, that's what will happen.
Yep. And so you can, and just so you can see that we're actually returning the T result type there. So
Okay.
I think the next thing we want to take a quick look at is the task from result.
Right. So yeah, there's that I find is a great convenience method for when I'm working with tasks and I don't know exactly what it is that, or when I'm testing and I want to mock out something that maybe say a network call that's going to return a task of stream, and I want to write unit tests for it. I can create a task that's already completed and has a result that I want. So that's kind of where I find that one really, really useful.
Okay. Yeah, so let's go ahead and take a look at the code here. We have this is a static function on that task object that we had originally seen. And what they're doing here is allowing you to pass in a type and then create a new task, the task of T result from it. And this is a great example of using generics at the method level and not at the class level.
Right, so it's kind of using both here. That task.fromResult is a static method, so it's going to be a generic method. And because of its types and what it returns, it's going to implement, or it's going to instantiate a task of whatever type we want, and then return a task that's already got a completed value in it. And its state is set to already run to completion successfully. Okay.
Yeah, and so I think what's important here is that this task can run and return any type of information, but the async infrastructure that's relying underneath it is going to stay the same. So
right. So once again, as we talked about with it, walking through the PowerPoint and some of the concepts around this, is all the infrastructure in the VCL to be able to say, I'm going to start a task that does a whole bunch of work, and all the infrastructure to say that task finished or that task faulted because it generated one or more exceptions running asynchronously, or that task is still running, it's not done yet. All of that is very generic, no matter what the particular task is doing. The part that would be specific maybe to our code is what result gets generated from that asynchronous work and what type that is and how I'm going to process it once it's already back. And that's that T result parameter. So from the generic standpoint, a task returns some object eventually. And now we can have type safety around that some object eventually part. So, and with that, let's look at what the lab exercise is here. So when we built our code in the first 3 modules, we stayed away from generics because we hadn't covered the concept. So now what we want to do in this lab is I want to revisit the implementations that we've put together so far and look to see if using generics would get us more type-safe code in the things that we've built. Is our implementation using the classic collections anywhere? A couple of them we looked at yesterday, and they are. We want to replace those with the type-safe version, with the generic version of those collections to avoid being able to put the wrong things in those collections. And we want to look at those type parameters carefully so that we can preserve the polymorphism I want. Like if I want to be able to treat a teaching assistant or a teacher the same, that would mean that my type parameter should be that interface that we developed. Or if I don't want to, if I want a specific only the main instructor, which has to be a teacher object, well, we should put that in place. And in fact, once again, if I want all the students, would that also include the teaching assistants because it's derived from it? It would, right? Because if I make a list of student, because teaching assistant is derived from student, I can put a teaching assistant in that list because a teaching assistant is a student, right? So I don't have to always pick just the leaf classes of something. I can pick a base class in my hierarchy where I want the polymorphism. So I want a collection of all students, which includes the TAs. So that would be one of the things that we can look for as well in this lab. And with that, we'll let you work on that for a while, come back, and we'll discuss the solution that we built.